Okay, in this section of 3.1, we're going to talk about exponential growth or decay formulas. And these formulas can be used for other things besides just compounding interest. So, N is going to represent the final amount of whatever we're talking about. N sub 0 represents the initial quantity. That was what was principal a while ago in our with the compound earlier in our compounding interest. The regular exponential growth or decay, your rate is still going to be a decimal, and it's R, and then T is still the amount of time. Okay. Now, if it's growth, it'll be plus R. If it's decay, then the R is going to be negative. It'll be 1 minus R. Okay. Then our continuous exponential growth or decay. The N, again, is the final amount. N sub 0 is the initial amount. And then, of course, we have our E. And then K is rate in this problem. It's the same as the R over here. And then T being your time. And again, K is going to be, if it's growth, it'll be positive. The rate will be positive. If it's decay, then the rate will be negative. And it talks about being careful about that down here. Okay, so we're going to do some, I believe, that have to do with population. Okay, Mexico has a population of approximately 110 million. If Mexico's population continues to grow at the described rate, predict the population of Mexico in 10 and 20 years. So this is a growth, okay? So our T is going to be 10, and then we'll do it again for 20. Our initial amount, N sub 0, that's the starting population, is 110 million. Now, for A, we're going to be using not the continuous, but the regular one, which is N equals N sub 0, 1 plus R to the T power. Is that right? Go back and double check that. Yes, 1 plus R to the T power. Whoops. Went to a completely different page, didn't it? This is not working. There we go. Only got to work a little bit. Okay. So our R is going to be the decimal of 1.42%. So R is going to be, we'll move the decimal 2 places to the left, 0.0142. Okay. Alright, so let's plug that in and find out and predict the population. So N equals, and we'll go ahead and just leave this as 110 and we'll deal with the million part later. That means that when we get our answer, we'll have to convert it to millions. And then 1 plus 0.0142, or that's the same as 1.0142 to the 10th power. And I believe when you put that in your calculator, you will get 126,656,869. Okay, now let's do the same thing but predict after 20 years. So everything's going to stay the same, except we're going to raise it to the 20th power. You put that in your calculator and you'll get 145,836,022. Okay. Alright, now we're going to move down over here. And now we're going to do continual. Same rate, but continual. So our formula that we're going to use is n equals n sub 0 e to the kt power. Okay, and this time our n sub 0 is still 110 million because the problem didn't change, just the function did, or the formula. K is the 0.0142, and then T is going to be 10, and then we've got to do it with also 20. Alright, so we're just going to plug this into this formula. So n equals n sub 0 110 e to the 0.0142 times 10 power, which would be 0.142, but you can just put it in the calculator like that, and you will get 126,783,000. I believe it's 431. Okay. So you can see it's a little bit more than the previous, than example A. Alright, then for our second part, we're going to leave everything the same except our T is now 20. And you should get 146,127,622. Okay, so your exponential growth and decay can be used for more than just compounding interest. And this is an example of population. Okay, and I'm going to stop this video here, and this will be part 5, I believe.